We're going to go over today over a rather simple GMAT question. And the reason for going over it is to emphasize the importance of pausing at the stem, at the question itself, and to pick the fastest method that you know to solve the given quant question. In this case, the question states that x over y is equal to 2 over 3, or 2/3. And then what we're trying to find is the value of x minus y over x, right? So today, the way to do this is to basically try to merge the two terms. Meaning with merging is try to convert what we're looking for. In this case, we're looking for the value of x minus y over x, right? So how can we convert these terms to have or to show or to be able to use what is given, which is x over y? One way of doing so is by dividing the numerator by y and dividing the numerator and denominator, dividing them both by y. Or we can think, which is the same thing as basically multiplying the numerator by 1 over y and doing the same thing with the denominator. So if we do that, what do we get? We end up getting x over y, because x times 1 over y is x over y, minus y times 1 over y is basically y over y. And this whole thing is divided by x times 1 over y is x over y. And look what we got now. Now we have the terms that is given. We have x over y in the equation. So this is our x over y that we have, and this is another x over y that we have. So basically we substitute for those. So instead of x over y, I would write 2 over 3, which is given right here, right? And then a minus y over y is a 1, divided by, again, x over y, which is given as 2 over 3, or 2/3, right? So this is basically one of the fastest ways of solving this problem. Now, when we get to fractions, again, you have to know your fractions. I cannot emphasize this enough. One way, again, this is not the only way or the only fast way. I'm sure if somebody is pretty fast at it, you don't have to follow this method. But one way for when you have fractions like this, whenever you have a division and you have more than one fraction in the denominator and or the numerator and the denominator, one way of doing it, of solving it fast, is to get rid of the fractions, get rid of the denominator in one shot. So in this case, for example, I have the first denominator I have is this 3, right? The second one is 1 over 1, so I have a 1 in here. And then in the denominator, I have another denominator here, which is the 3. So the numbers in red are actually the denominators for the individual terms in this whole equation, if you want to call that. So what is the least common denominator between the 3 and the 1 is the 3. So what do? Basically, I multiply the denominator and the numerator and the denominator. I would multiply them both by the least common denominator. And the least common denominator in this case is 3. So if I multiply this by 3 and this by 3, what do I get? 3 times 2/3 is what? Is a 2, right? 3 times 1 is what? Is a 3. So 3 times 1 is a 3. So that's 2 minus 3 divided by 3 times 2/3 is a 2. And look what we have now. We get rid of all the fractions in one step, and the answer is going to be negative 1 over 2. Or negative half, and this is basically the answer. So going over this question, I know it's a simple question, but the importance of it, two things. The most important lesson from this question is to pick the fastest way, to pause at the stem and choose the best method, the fastest method to solving the question. In this case, we try to find or change what we're looking for. We try to change or get to the term x over y, and then by getting that there, then we were able to substitute 2/3 for the x over y. And the second thing we learned here is whenever you have these fractions in the numerator and the denominators and you have more than one, right, you can find the common denominators between all of them, right, which is the red numbers in here, the 3 and the 1, and multiply the numerator and the denominator by the least common denominator, right? So this is how we got -1/2. Well, I hope this helped. And then we'll talk next time with more quant questions.